Hi, this is Ethan Nowaski with the Week 9 Explainer video talking about how refrigerators work. So to start off, this is our diagram of a practical refrigerator and the different components that compose of the refrigeration system itself. So we gotta first talk about what it actually is comprised of. We have the fridge itself, which we want to get cooler. We have a compressor, an expansion valve, the evaporation and condensation coils, and then running through all of these parts will be the refrigerant itself, which will be storing and conducting our heat and energy. So let's start with our expansion valve being kind of our step one, or point one. So from here, what the expansion valve does is it causes an adiabatic expansion. And what this does is it greatly decreases the temperature of the refrigerant by expanding the volume and so therefore decreasing the temperature and pressure. And so it really gets the refrigerant very, very cold. And so when it gets very, very cold, it runs through this coil into the refrigerator itself. And because the refrigerant is so cold from the adiabatic expansion in the expansion valve, the heat, the refrigerator itself, the environment of the refrigerator will technically be hotter than the refrigerant. So the heat will go from hotter to cooler according to the second law of thermodynamics. So we have heat actually being transferred into the refrigerant in these coils right here, out of the refrigerator itself. And you know, when you take heat out of something, it becomes cooler, hence why the refrigerator becomes cooler itself. So that's kind of where we tend to focus the most on, but there's these other parts that we need to consider as well if we want this process to cycle and continue. So we take the heat into the refrigerant, it comes out of the refrigerator, and then it leads into this compressor. And this compressor is very important because it is where the work for the system is actually being put in. So what's happening is kind of the opposite of the expansion valve. It's causing an adiabatic compression, hence compressor, where it's decreasing the volume so much that the pressure and the temperature of the refrigerant is going to increase. So the pressure and temperature is going to increase. That's very important. So it's increasing, the temperature of the refrigerant is increasing so much that it's actually hotter than the outside environment of the real world. And this is where heat is, again, according to the second law of thermodynamics and entropy, where heat is going to be flowing from hotter to colder. And in this case, the colder environment is outside of these coils. Hence, that's where the heat from that's being taken in these coils right here is being transferred out, kind of. And then we lead back up into our expansion valve, and the process repeats all over again. So here's what our kind of system looks like in a pressure versus volume diagram, which we may be a little bit more comfortable seeing because this is more so what we see in the book. This is kind of, this is our expansion valve right here, point one. And this is flowing this way in an adiabatic expansion right here to point two right here. And then it takes in the heat from the refrigerator, and then and then there's an adiabatic compression from 3 to 4. This is where the compressor would be, where the work is being put in. And then you have this part right here where the heat is being taken out of the system and into the rest of the environment. And so if you look at this looks very familiar, and it's kind of the opposite flow of a heat engine. So it's technically a reverse heat engine in itself. So just to kind of repeat the main points of this video. So the second law of thermodynamics isn't being intruded upon at all, actually. It's being followed perfectly as we continue the trend of hot going to cold. And from our pressure versus volume diagram, we can see clearly that this is this refrigeration system is actually a reverse heat engine in action. So that's how refrigeration works. And that's how things get colder, by basically having something colder pull the heat out of it. All right, thank you.